Okay, now it's recording. Perfect. All right. So yeah, guys. So yeah, just to remind you, so we can do, operations. I mean, the usual operations on functions, addition, subtraction, etc. So we can do algebraic. So we can do algebraic operations on functions. So what do I mean by algebraic operations? I mean, for example, so addition, right? And the additional functions, it's denoted by, so f plus g of x. So it's just f of x. It's just the usual operation. So it's just f of x plus g of x, right? And then we have, of course, subtraction. So we can subtract functions. So f minus g of x. So that will be f of x minus g of x. And then, so this is subtraction. Of course, there is a multiplication. And then division. All right, so multiplication would be f times g. This is just the same notation, f times g of x. So it's just f of x multiplied by g of x. And then division, we denote the division by f over g. And so when you say f over g of x, it's just f of x divided by g of x. Right. Anyway, so now, so what we tried to do last week, Wednesday last week, is, we try to find the domain of f plus g, f minus g, etc. So just to remind you, so we had the following theorem. So we said the domain of f plus g, or f minus g, or f times g of x is the domain so here, of course, plus minus times. It's just probably I should write this way. So the domain of f times g. So the domain of f plus g, f minus g, f times g is the common domain and that's so the intersection of the domain of f with the domain of g. So domain of f intersected with the domain of g. Okay. So we take the intersection of the two domains. Right? So that's what I call the common domain. It's the intersection domain. Now, for f over g, we need to avoid the division by 0. So we need to exclude the values where g of x is 0. So the domain of f over g is, well, again, it's the common domain, but we need to exclude the values where g of x is 0. So it's the common domain with values where g of x is 0 are excluded. All right, so we need to exclude the values where g of x is 0 from the intersection, from the common domain. All right, so yeah, as I said, I think we had an exercise. Well, before the exercise, So yeah, I'm gonna do an example just to remind you of the steps, guys, right? So an example. All right, so let's say you have the following functions. So let's say my f of x is square root of x plus t. G of x is square root of 1 minus x, right? And then you want to find, let's say you want to find the domain of, f plus g, f minus g, f times g, and f over g. Okay, so all right, so in this example, so the goal here is not really to compute f plus g or f minus g or f times g, etc. Right? So I mean, you don't have to compute like f plus g of x. Of course, that would be like f of x plus g of x. So then f of x is supposed to be the square root of x plus t plus, and then g of x is supposed to be square root of 1 minus x, right? That's my f plus g of x. But here in this exercise, you don't have to compute f plus g of x. That's not the point here, okay? You need to find the domain. And so if you want to find the domain of this f plus g or f minus g or wherever, you need to use our theorem. And so we need to find the common domain. So because the common domain or the intersection domain is going to be the domain of f plus g, etc. So the goal here is really to find this intersection domain or common domain. So we need to find, so the goal here is to find the common domain. All right. So to find the common domain, we need to find, so there are a couple of steps. So first step, you need to find the domain of f. Find the domain of f. Okay. So what do I mean by finding the domain of f? Again, it means that the domain of f is the set of all x values that you can input in this function f, right? So, because there is this square root, right? There's a square root, and you are not allowed to have negative numbers under the square root, right? So, because of the square root, you need to make sure that what's under the square root is larger or equal to 0, right? Because you're not allowed to have negative numbers under the square root, right? So this number here under the square root cannot be negative. It has to be positive or 0, right? So that's the thing. So to find the domain, in this case, when you have a square root, you have to solve. So because of the square root, okay? So whenever you have a square root, you have to solve what's under the square root larger or equal to 0. Make sure that what's under the square root is positive or 0. Okay, so in this case, for example, it's x plus t. That's what we have under the square root. If you have something outside the square root, you don't really care about it. Okay, so you only care about what's under the square root. So under the square root is just x plus t. Okay, I mean, I can, if I want, I can just, for example, change my function f and have like, I don't know, -4 outside or -4x or wherever. It doesn't change the domain of the function f, right? Because we don't care about what's outside this the square root. So under the square root, we have x plus t, and so we need to solve x plus t larger or equal to 0. Okay, larger or equal to 0 means it's positive or 0. Okay, now we want to solve for x. So let's solve for x. You just subtract So you just do the usual, solving. You subtract 3 from both sides, so then your x is larger or equal to -3, right? So what we are saying here is that your input x, the input x, it must be larger or equal to -3. In other words, like on your number line, which goes from -infinity to +infinity, so you have -3 somewhere, so your x must be larger or equal to -3, so it must be on the right side of -3. So the domain would be like, on the right side of -3. This is where x is larger or equal to -3, and it's equal, so x can be equal, right? So we need to include this -3, right? So -3 is included, right? Because it can be equal to -3. So yeah, so then the domain of f is just to answer this first step. So domain of f, so this d subscript f, that's the notation for domain of f. So domain of f would be like, so it's like from -3 to +infinity. -3 included, +infinity is always excluded. All right. So that's for the domain of f. That's the first step. Now I need to find, second step, I need to find the domain of g. Of g of x. So let's see what's g. G is square root of 1 minus x. So it's the same. It's the same idea here. Because of the square root, we need to solve what's under the square root, larger or equal to 0. Make sure that this 1 minus x is larger or equal to 0, is positive or 0, in other words, right? So I need to make sure that 1 minus x is positive or 0. Positive or 0. Yeah, and it's just the same inequality, right? Larger or equal to 0. Now, if you want to solve for x, different ways to solve here for x. Probably the easiest way would be to, you can just, subtract or add x to both sides. So if you add x to both sides, so plus x, so then +1 on the left is larger or equal to x. So yeah, so what we are saying here, guys, is that x, so +1 is larger or equal to x. So 1 is larger or equal to x. So in other words, x is, so if 1 is larger or equal to x, then x is actually less or equal to 1. Right? This is the same thing. That's just equivalent, right? 1 larger or equal to x, it's equivalent to x being less or equal to 1. It's just the same thing, right?
Excuse me, Professor.
Yeah, please. Yeah.
Maybe I missed something.
Yeah.
The g of x is square root 1 minus
x.
X. I wrote it down. Okay. I wrote it down wrong.
No problem. Yeah, so so on the number line, from -infinity to +infinity, so let's say here's 1. So 1 is larger or equal to x. It means that your x is on the left side of 1, right? So x, it's actually less or equal to 1. So it's going to be on the left side of 1. And of course, it can be equal or equal, it can be equal to 1. So we need to include 1. So the answer in this case, so the domain of g, d subscript g, that will be -infinity to +1. Infinity is always excluded, and +1, again, here, it's included. All right. Any other question, guys? So whenever I want to find the domain, guys, and this is like a very general rule, you have to check two things. If you have a square root, you need to make sure that what's under the square root is larger or equal to 0. If you have a division, of course, you need to avoid division by 0. You are not allowed to divide by 0. So if you have a division, like you have a fraction, you have to, solve the denominator equal to 0, just equal to 0. You don't really care if it's positive or denominator, if the denominator is positive or negative, it doesn't matter, right? What's really important for you is just make sure that it's not equal to 0. So just if you have a fraction, just solve the denominator equal to 0. If you have a square root, you need to make sure that's under square root is larger or equal to 0, positive or 0. So that's why we have an inequality here when you have a square root, right? Anyway, so yeah, we got the domain of G, we got the domain of F. Now I can find the domain of the intersection domain or common domain. And this is step number 3. So find the common or intersection domain. Common domain, right? So my number line. So I'm gonna graph or draw the domain of F. Domain of F, we said it's -3, positive infinity. So I'm gonna need -3. Domain of F is -3, positive infinity. -3 is included. So this blue interval would be the domain of F. That's the domain of F. All right. Now, domain of G. It's from -infinity to +1. So we're going to need +1, which is, of course, on the right side of -3, right? Because +1 is larger than -3. And then so domain of G is going to be this green interval. So from -infinity to +1. So that's the domain of G. The green interval, right? Now the intersection domain would be the domain which is, sorry, the interval which is at the same time blue and green, right? So that will be this interval right here, right? This is my my intersection, the intersection between the blue and the green intervals, right? So this is intersection domain or intersection interval, intersection domain. Okay, or common domain. Right, so then yeah, to answer this is step number 3. So I know now the domain of F plus G, F minus G, F times G. So the domain of F plus G, F minus G, F times G, all right, is the common domain. Okay, so that will be, so domain of F, D subscript F, intersected with the domain of G. So that will be from -3, right, to +1. Again, that's my red interval, the intersection between the green and the blue intervals. So -3 is included, right? So as you can see, -3 it's in the blue interval, it's included in the blue interval, and it also belongs to the green interval, right? So it's in the intersection of the two domains. So -3, it's a common value in the two domains, right? So -3 is included. The same for +1. And actually, I forgot to include the +1 right here in the green interval. So +1 is in the green interval, and it's also in the blue interval, right? So it's it belongs to both domains, right? So it's included. So that's my intersection domain, right? So that's the domain of F plus G, F minus G, and F times G. We are not done yet because there's F over G. So this is step number 4. Step number 4. So for the domain of domain of f over g. Okay, so the thing is, because we have a division by g, right? It's a fraction, it's f over g. So we need to exclude the values where g is 0. So we need to exclude the values where g of x, I mean the values of x, of course, where g of x is 0. We exclude them from, of course, from the common domain. The common domain. So we need to know where g of x is equal to 0, not large or equal, not positive or negative or wherever, it's just equal to 0, right? So we need to solve g of x. We need to know where g of x is 0, right? So we need to solve g of x is equal to 0. Okay, I don't care if g of x is positive, all right, just equal to 0. So g of x is 0. G of x, it's the square root of just to remind you, g of x. So g of x, again, it's a square root of 1 minus x. So square root of 1 minus x equal to 0. All right, so first thing to do, guys, of course, when you have such an equation and you want to solve for x, there's this square root. So get rid of the square root. You just apply, you can just apply square both sides. So here's a square and here's a square. And because of the square root right here, cancel out. So it's just now 1 minus x equal to 0 squared. 0 times 0, of course, is just 0. So this is just 0. And then you add x to both sides. So it's going to be just 1 on the left and x on the right side. So this is where g of x is 0. So when x is equal to 1, right? It makes sense, right? Because if x is 1, 1 minus 1 would be 0. So square root of 0, of course, is just 0 because 0 times 0 is 0. So we need to exclude this. So we exclude the solution from the common domain. Right? So then the answer for the domain of f over g is, so as you can see, guys, I mean, this is your intersection domain, right? This interval -3, positive 1, that's your intersection or common domain. So what we need to do is to exclude the positive 1 from this -3 positive 1. So we need to exclude 1, right? So then the answer would be -3. So this domain of f over g is -3 positive 1, and we need to exclude the positive 1, right? So we need to exclude this positive 1 right here. -3 is included, of course. So as you can see, that's the unique difference between, that's the only difference between the intersection, the domain of f plus g, f minus g, f times g, and the domain of f over g. That's the only difference. So that's, yeah. So that's the domain of f over g. Just one more remark, guys, before the exercise. One more remark is that, so if you want to find, let's say, the domain of g over f, so if, let's say, you want to find the domain of g over f, so here, g over f, we are dividing by f, right? And so because we are dividing by f, we need to make sure that f is not 0. So here we are dividing by f, right? So if you want to find the domain of g over f, we need to exclude the values where f is 0 from the common domain. So to find the domain of g over f, find the domain of G over F, we need to exclude the values where F is 0, where F of X is 0. The values of X where F of X is 0. Right? So that would be, of course, that's F of X is equal to 0. That's a different equation, right? So because F of X is, F of X is the square root of X plus T, right? That's my F of X. That's the square root of X plus T. So we need to solve square root of X plus T is equal to 0. So we need to solve square root of X plus T is equal to 0. All right, so same thing here, same apply square root. So that's just X plus T now equal to 0. You subtract T, and so your X is negative T. Right? So domain of G over F. So then this is the answer for domain of G over F. So domain of G over F is, so we need to exclude this negative 3 from the common domain. So we need to exclude this negative 3 from the common domain, right? So the common domain is, again, it's this domain.
Yeah, I have.
Right here.
Thank you.
So the intersection domain is this negative 3 positive 1, right? And now for G over F, we need to exclude the negative 3. So that will be, so the domain of G over F is now negative 3 excluded, right? And then comma positive 1. Positive 1 is included here, okay? So as you can see, well, there is a difference between the domain of G over F and F over G, right? So as you can see, in the domain of F over G, we excluded 1. In the domain of G over F, we excluded the negative 3, right? Because we have a different denominator. Any question, guys? Okay, perfect. So here's an exercise for you then. Exercise. Okay, so please try to find domain of, so F plus G, F minus G, F times G, F over G, and G over F of, so where F of X is, so where so F of X is equal to, let's see, yes, so F of X is actually square root of X, let's see, X plus 1. Okay, and G of X is equal to, let's see, it's a square root of let's see, yes, 4 minus X minus 2. All right. Yeah, the minus 2, guys, is, again, it's actually outside the, this is outside the square root. Okay. All right. Let's say you have like 5 minutes to think about this exercise. So this is just this is outside. By the way, guys, if for some reason you cannot enter the campus, for for the test, because again, the test is going to be on Wednesday. That's in person class. So if for some reason, for vaccination reason or whatever, you cannot enter the campus, please let me know. Okay, please email me in advance. All right. So you're saying so -1 4. That's correct. Yes. So you mean for f plus g, f minus g, f times g, the -1 4. Yes, that's correct. Yes. That's correct. You mean that the 4 is included, right? So Bayesian, you're saying how? How he got the -1 4? Well, well, if you just try to follow the steps we had in the steps in the previous example, if you try to find the domain of f, then domain of g, and then take an intersection of the domain. Oh yeah, he gave the common domain. Yes. Okay. Matthew, you're no problem. Matthew, you're saying it's -1 4. Yes, but the -1 and 4 they are included, right? So we are talking about, because we are talking about f plus g, f minus g, f times g, I guess. So -1, 4. Yes, is the domain of so f plus g, f minus g, and f times g. All right. Okay. And now you need to be careful. So f over g. That's not true actually. For f over g, and so for f over g, it's not f over g. It's not -1, 4. The 4 excluded. That's not true. Oh yeah, of course there are different answers. Yeah, for each. I mean, well, even in the previous example, so the domain of where is it? Right here. As you can see, this is the domain. Like this is the domain of f plus g, f minus g, f times g, right? And as you can see, -3 and +1 both are included. Okay, and then for the domain of f over g, we excluded the 1. Okay, so that's different from the common domain, of course. And then for g over f, it's also different. I mean, from the common domain. For g over f.
What I'm trying to say is, like, say you put it on the test and it's a multiple choice. Do you, like, what answer am I supposed to put? Do I put all of them put together, so like both will be excluded, or do I put like only f over g and only like f plus g, f minus g, and f times g? So I'm trying to say, because you put all
In
5,
the test.
so it
Yeah,
should
in
be
the test.
excluded.
Oh yeah. In the test, yeah, you have like 3 different answers. So you say, well, for f plus g, f minus g, f times g, that's -1, 4, both included. For
Okay,
f
so
over
then
g,
you put 3 answers.
yes, you
Okay,
put
okay.
there's different answers.
That's all I was trying to like say.
Sure. Yeah, that's a good point. There are 3 different answers. Yeah. And actually, for f over g, guys, it's not -1 for excluded. So be careful here for the where g is 0. Don't forget there's -2 outside, right? So when you solve g is 0, the -2 actually matters. I mean, that's important. Yes, Jaffer, excellent. So that would be the domain of f over g. Yes. Yes. Yeah, very good. That's the domain of that would be the domain of f over g. Yes. Domain of G over F. Yes. Yeah. Very good, Jaffer. Yeah. Absolutely. Yeah. Patient F over G. All right, guys. Does anyone need more time? Okay. All right. So let's do this. All right. So step one. So in this first step, we need to find the domain of F. Domain of F of X. So here's the same, the same thing as the previous example. We have a square root, and so we need to solve what's under the square root larger or equal to 0. So we need to solve x plus 1 larger or equal to 0. We need to make sure that what's under the square root is positive or 0. So if you subtract 1, then x would be larger or equal to -1. So on your number line, your x must be on the right side of -1. It's larger or equal to -1. So we need to include the -1, of course, right? So then, so the domain of F, it's -1, positive infinity. All right, now step number 2. We need to find the domain of G. Right? And again, so in G, we do have the square root. And so we need to solve what's under the square root larger or equal to 0. And under the square root, it's 4 minus x, right? We don't care about the -2. So we need to solve the 4 minus x larger or equal to 0. So we need to solve the 4 minus x larger or equal to 0. And so if you add x to both sides, of course, you can also subtract 4. But then the thing is, you're gonna end up with minus x, which is not exactly x. So then you have to multiply by -1, etc., etc. But probably it's better just to add x to both sides. So once you add x, so it's gonna be 4 on the left, plus 4 on the left, and exactly x on the right side. So here, what we are saying is that 4 is larger or equal to x. So if you say 4 is larger than x, means that x is less than 4, right? Larger or equal to x. So in other words, x is less or equal to 4. Okay, so on your number line is 4, negative, positive infinity. Your x is less actually than 4. So then less than 4, that would be the interval on the left side of 4. So it's going to be from negative infinity to 4. 4, of course, it's included because it can be equal to 4. X can be equal to 4. So then, yeah, so then the answer, domain of G, will be negative infinity to 4, the 4 included. And then now, the
I'm
intersection
sorry,
domain.
Professor, excuse me.
Yes, please.
Are the number lines part of the answer that you want
No,
included?
no, just
Okay.
no. I'm using the number line just to explain the answer.
Okay, thank you.
So step number 3, the common domain, intersection domain. So here's negative infinity, positive infinity. We have first domain of f. Domain of f, we said, here's the domain of f. Oops. Here's domain of f, right? We said it's -1 positive infinity. So -1 positive infinity would be this domain right here. And then domain of, so this is domain of f, domain of G. It's from 4, sorry, it's from negative infinity to 4. So I'm going to need 4. 4, of course, it's on the right side of -1 because 4 is larger than -1. And then it's, so domain of G would be, I'm going to use the same color, the blue. So it's from negative infinity to 4. 4 included. And as you can see, the intersection or the common domain would be the from -1 to 4, right? So then the intersection domain or the common domain so that would be the interval, the blue and red at the same time. So that would be this interval right here. That's my intersection domain from -1 to 4. So that's -1 to 4. Both -1 and 4 are included. All right, so that's the answer for domain of f plus G. Domain of f plus G, f minus G, f times G is, so this -1, 4. Both are included, -1 and 4. All right, so now next for f over G. Okay, so f over G, that will be step number 4. So domain of f over G, right? So what we need to do, guys, we need to exclude the values where G is 0. As you can see, again, we are dividing by G, and we're not allowed to divide by 0. So we need to make sure that the denominator is not 0. Okay, so we need to solve where the denominator is 0, and then exclude the answers or the solutions from the common domain. So we are dividing by G, so we need to solve. So we are dividing by G. Okay, so G cannot be 0. So we need to solve. So we need to solve G of x is 0. So so what's G of x? G of x is, this is a square root of 4 minus x minus 2. 4 minus x minus 2. So this is square root of 4 minus x minus 2. That's the whole thing is my G, right? So I need to solve G, this whole thing here equal to 0, all right? So that's why we need to include the -2 here, because I'm solving g of x, my function g, and -2, of course, is it's in the function, right? So we need to use this -2. I need to solve this. Of course, first thing to do is, well, we cannot really apply the square root to this the square to the square root, because there's this -2 right here. So I need to move first this -2 to the, or -2 to the right side. So I'm gonna add +2 to both sides. So then it's just now square root of 4 minus x on the left, and +2 on the right side. Okay, and now I can get rid of the square root. So now I can apply my square both sides. So here's a square, here's a square. So then now it's just 4 minus x on the left, and on the right side it's 2 squared. That would be 2 times 2. So that would be 4. Okay. Now we need to solve for x. We can subtract 4 from both sides. So it's just, so 4 minus 4, 4 cancel out. So it's just minus x now on the left. And on the right side, it's 4 minus 4. So it's just 0. So minus x is 0. Again, we need to get rid of this minus. So we can multiply, we can multiply by, or divide by -1. So let's divide here by -1, both sides. And so when you divide by -1, negative over negative, will be positive. So it's just x now on the left. So it's x equal to 0 over any non-zero number is 0. Okay, so your x is 0. So the thing again, guys, is that, so when x is 0, as you can see, if your x is 0, 4 minus 0 would be 4. So square root of 4 would be 2. And then 2 minus 2 would be 0. So if x is 0, your g of x is going to be 0, right? And so we need to exclude the values where g of x is 0. So we need to exclude this, the solution from, we need to exclude this from the common domain. Common domain. Right? So yeah, so then the answer would be, so the common domain, it's from, from -1 to 4. -1 to 4. That's my common domain. Right, this is my common domain. And what I am saying, this is my common domain. And now what I'm saying is that I need to exclude 0 from the common domain. And 0, it's between -1 and 4, right? So 0 is somewhere right here. So we need to exclude the 0, right? So then if we exclude the 0, so you're going to have like parentheses here at 0, right? Because we are excluding 0. So the domain of, answer here. So domain of f over g is, so it's from -1. And then we have to stop at 0 because we are excluding 0. So we stop at 0, 0 excluded, -1 here is included, and then union with another interval, which is from 0 again excluded to 4. 4 is included, of course, right? So here again, the 0 is excluded. 0 is excluded. All right, so that would be the domain of f over g. Now, the domain of g over f. So this is step number 5, I think. So domain of g over f. And so here we are dividing by f. So when you divide, you have to solve your function equal to 0. So we are dividing by f. So we need to solve f of x equal to 0. And then we have to exclude the answers from the common domain. So f is 0, f is the square root of, where is it? Square root of x plus 1. And so it's just square root of x plus 1 equal to 0. So here, you know, we can just apply the square both sides again, square, and so it's just x plus 1 now equal to 0. You subtract 1, so it's just x equal to negative 1. All right, so we need to exclude this from the common domain. Exclude this from the common domain. Common domain, again, it's from negative 1 to 4, right? Negative common domain. So so again, my common domain is this one right here from negative 1 to 4. Right, this is my common domain, and what we are saying is that we need to exclude the negative 1. So I'm going to put parentheses at negative 1, right? Because it's excluded. So the answer domain of G over F is actually negative 1 excluded, and then 4 included. Okay. So as you can see, guys, we got like 3 different answers. There's one answer for f plus g domain of f plus g, f minus g, f times g. There is another answer for g over f, and there is also there's another answer for for f over g and g over f. Okay. Any question, guys? All right. Okay, so I guess we are done with this combination of functions, operations, algebraic operations on functions. We know how to add, subtract, etc. functions. We know how to find the domain. Now the next operation and last operation actually is called the composition of functions. All right, so next. Next operation, it's a composition of functions. Composition of functions. All right. So the idea is the following, guys. So what's a composition of functions? So let me start with an example. All right. So we have 2 functions, f and g. So let's say, for example, f is, it's x squared minus 3x plus 2. All right. And then I have another function g, which is, let's say, just x plus 1. Right. So we have 2 different functions, f and g. And as you know, we can add these 2 functions, we can subtract them, we can multiply them, etc. Now, there is another one more operation we can do on these 2 functions, f and g, is the following operation. So what we can do is we can compose these 2 functions. So what I'm going to do, I'm going to replace x by g of x in f. So here, I'm going to compute f of g of x. Okay. So what I'm going to do is I'm going to substitute x. You see this x right here, this green x. So I'm going to substitute x by g of x. Okay. So so whenever you have x, like there's an x in here, and there's another x here, right? So I'm going to just replace the x with the g of x, right? So that will be, so f of g of x is equal to, so this x would be g of x. G of x is x plus 1, right? Here's my g of x. It's x plus 1. So here, it's going to be x plus 1. And here, instead of x, I substitute x by x plus 1. So, and then there's a square right here. There's a minus 3. And then there's plus 2. Okay. So I just replaced x by x plus 1, which is g of x. All right, now let's compute this thing. So what's f of g of x? Again, you think of the circle like a parenthesis. So this is like x plus 1 between parentheses, and then there's a square outside, minus 3 times parentheses x plus 1, plus 2. So this is f, or this f of g of x. So it's going to be, so x plus 1 square, this is like x plus 1 times x plus 1, right? And then there's this minus 3 times x plus 1 plus 2. So let's just try to simplify this thing. So f of g of x. So we distribute, you multiply this x here by x and this x plus 1, x by 1. And of course, you do the same thing here with 1. 1 times x and then 1 times 1, right? So this, so it's going to be equal to x times x, it's x squared. X times 1, it's x, plus now 1 times x. So that would be x, plus 1 times 1, that would be plus 1. Right? And then we're going to do the same thing with the 3. We're going to distribute, so 3 times x and then 3 times 1. Right? So this is minus, so it's minus 3x. And then don't forget the sign. As you can see, this is minus right here. So minus plus will be a minus. So it's minus 3 times 1, of course, it's 3. So it's minus 3, and then plus, and then there's plus 2. So this whole thing, f of g of x, this f of g of x, it's actually equal. So let's see. First, how many x squared? We have just one x squared right here. So it's just x squared. Now we count how many x's. So it is plus x, that's plus 2x, and then minus 3x. So 2x minus 3x, 2 minus 3, it's minus 1. So that's minus x. So here it's going to be minus x. And then the constant. So as you can see, there's plus 1, minus 3, that's minus 2, plus 2, that will be 0. Right? So f of g of x, it's just equal. So this is a plus 0 actually. So f of g of x is actually equal to x squared minus x. So the thing here, guys, as you can see, I started with like 2 different functions, f and g, right? F is x squared minus 3x plus 2, and g is x plus 1, right? And now I got like a new function, right? This is x squared minus x. Like this is different from f and g, right? This is a new function, right? And again, this is not, it's not f times g, so be careful. The space between f and g here, this is not f times g, this is f of. You see the space right here, the between f and the parentheses, that's off. So that's how we read this thing. So this is f of g of x, right? This is also off here. Okay, so it's not multiplication here. I'm not multiplying f by g. This is f of g. Okay, so notation we use for this thing here, for this composition, is the following. So when we write, the following, f composed with the g. So this circle here means a composed. So f composed with g of x. This is f of g of x. Okay, and as I said, again, this is not, it's not multiplication. This is not multiplication. This is f of g. All right, f of g of x. Okay, so this is what I call composition of two functions, right? This is f composed with g. So f composed with g. Okay. So what we do again, could you have, oh yeah, of course, Matthew. Yeah, absolutely. That's a good point. So we can also do, that's a good point. So now, yes. So to answer your question, Matthew, we can do g of f of x. Right? So how do we do that? How do you compute this thing? Well, first, I'm going to write down g of x. G of x is x plus 1, right? And my f was, let's see what was f. F was x squared minus the x plus 2. So f is x squared, sorry. So x squared minus 3x plus 2. That's my f, right? Now, if you want to compute g of f of x, so what we do, we are supposed to substitute x in g by f of x. So you see here this x in g of x. So we need to substitute this x with the f. Okay, so in g of x, there's this x. There's only one x, actually, this one right here, right? So I'm going to substitute the x with the f. Okay, and then there is this plus 1. Okay, so let's do this. So what will be g of f of x? So it's just first, it's just f of x. Well, this is my f of x. It's so it's this x squared minus 3x plus 2. That's my f. All right, and then there's this plus 1. Okay, so then g of f of x. So that will be x squared minus 3x plus 2. So here I'm supposed to have like parentheses. Okay, again, you need to think of the circle like a parenthesis. So the whole f between parentheses and then plus 1. Here the parentheses are not really needed because I mean there's no exponent or or I don't know. So it's just x squared minus 3x plus 2, and then there's this plus 1. So then g of f of x, it's x squared. Sorry, x squared. So it's x squared minus 3x, and then plus 2 plus 1, there'll be plus 3. Right, so that's my g of f of x. And as you can see, again, this is different from, so I got new function. This is a new function, right? This is a new function, and it's different from f. I mean, well, it looks like f, but it's not equal to f, right? Because as you can see, in f we have plus 2, and in this g of f of x we have plus 3, right? So it's not equal to f. It's different from f, right? So yeah. Yeah, we can do g of f of x. Absolutely. So yeah, so just be careful, guys. So then with the notation here, again, when you see this circle f, when you see this circle right here, this is a composition of two functions. It's not multiplication, right? So let me do one more example. Or, well, I can probably give you an exercise. I guess exercise. yeah, so please try to compute f of g of x, and yeah, and g of f of x. Okay. So let's see. So number one, f is yeah. So f is minus x squared minus x plus 2, and g and g of x is actually x minus 1. Right. Number two, f is this is more, I guess, more tricky than the previous one. So this is f is x plus 2 over, let's say, x minus 3, right? And then g of x, let's say g of x is just 3 over x. So yes, please, guys, try to compute f of g, f composed with g and g composed with f. Okay, so again, just to remind you, the notation here. So when I write f circle g, this is f of g of x, and this g circle f, that's g of f of x. So you need to simplify your answer, guys, right? So you need to do your best to simplify the answer. So next, guys, after the exercise, I will show you how to find this f composed g from the graph. So in number 2, as you can see, the f and g are fractions, right? So you need to be careful here because so you need to simplify your answer, and when you simplify your answer, you're gonna do like some sum or subtraction of fractions. So just be careful with the fractions when you simplify your answer. Now you're saying, let me see. So for f of g of x, minus 2x. Well, I think actually your second one, it's not. I don't think it's not correct. The g of f of x. I think this is incorrect. Now the f of g. I'm not sure. So for number 1, do you mean like the 1 x minus 1 square? You mean like x square? Let me see. Okay. X. Bayesian, you're saying for the 0 minus 1 plus x, is that number 1? No, I don't think so. Yeah, I think Nahar. Yeah, I think both. It's also wrong. Yeah, take your time, guys. No, Bayesian, it's not. Number 1 is not correct. It's not 0 minus 1 plus x. Nope. One f of g, is it x square minus 2x? No, Lewis, actually, nope. I think it's minus x squared, you mean, probably minus x squared.
Yeah. I
If
forgot
there's a
to
minus.
include the minus. Yeah, I forgot to include the minus.
Yeah, I think you forgot the minus. Matthew, same thing, Matthew. I think you forgot the minus for number one. Your number two is it's actually correct. Very good, very good. But number one, Matthew, I think you forgot there's minus one. I think you forgot the minus one. Jamie, you're saying for first one minus x squared plus x minus one. Let's see. For the first, yeah, Jamie, I think you're correct. I mean, I don't. Yeah, I think you're correct. Let me see. Lewis. Yes, now makes sense, Lewis. I think now it's correct. Yes,
Wait,
I
what?
think Jamie and Lewis. I think no. This is what? This is g of f or f of g. Let me see. You're saying this for g of f. For g of f, my plus one. Yes, that's correct. For g of f, that's correct. Lewis.
Mister,
Uh,
what was you talking about when you said that I forgot the minus one in the first question?
first,
The f of g or the g of f?
no, the f of g. You said f of g, it's x squared, right? Minus 3x plus 4. So there's a minus. There's a minus missing in front of the x squared for sure.
Okay.
Mm-hmm.
Wait, mister. After you distribute the negative to the x
Oh, yeah.
minus one squared, then you have to square the negative x plus one. So the negative x times negative x is x squared. That's how I got it to positive.
No, you distribute the negative sign just once. So it's like you have like negative x minus 1. So there'll be like
So
negative
you do the
x plus.
square before you distribute the negative?
Yeah, it's better to distribute the square before the negative. Yes.
Okay.
It's a PEMDAS rule, right? You go with the exponent first. You think of the negative like subtraction. So you go with the power, the exponent first, and then you do the minus or the subtraction.
Okay.
Mm-hmm. And no problem, Lewis. You can also try number 2. Please try number 2 because number 2 is also kind of tricky. I mean, not tricky, but different from number 1. I mean, number 2 is fractions. So you probably should try number 2.
Yeah, I don't know how I would substitute the 3 over x for
Right.
that x over x plus 2 over, and so I'll just wait for you to explain it.
Okay, sure, no problem.
Mister, for number 2, I got f of g is 2 over negative 3, and g of f is 3 over 2 over negative 3.
The f over g, you're saying 2 over negative 3?
Yeah.
F of g? No, I don't think it makes, no. I think it's incorrect, no. It's
Okay.
not correct, no. Okay, well, you know what, guys, let's do this because anyway, we don't have like too much time. So, and I really want to do this in details because it's kind of important. So Yeah, for number one, let's start first with the f of g. So let me just write down first f of x. All right, and this is minus x squared minus x plus 2. Now I want to replace x by g of x. So this x right here by g of x. So we do have an x in here and also an x in here. Okay, so that's this x right here and this x right here. All right, so yeah, there's a minus outside, there's a square right here, and x, it's, so g of x, of course, is x minus 1, so there's an x minus 1 right here. There's a minus, then x minus 1, and then plus 2. All right, so think of the circle as a parentheses. This is minus, parentheses, x minus 1 square, minus parentheses, x minus 1, and then plus 2, right? All right, guys, first, you see this thing here, minus x minus 1 square. So you need to apply PEMDAS rule. The square, this is like an exponent. This is a power, right? And we think of this minus as a subtraction. Minus is just a subtraction, okay? PEMDAS rule says, well, exponent comes first, right? So we do the exponent first. So let's do the exponent. So this is f of g of x. So there's this minus, and x minus 1 times x minus 1 minus x minus 1 plus 2. Okay, so this is actually, so let's just keep the minus. That's my subtraction. Now I'm going to multiply this thing right here. X minus 1 times x minus 1, right? So let's multiply this thing. Okay, so x times x, that'll be x squared. X times minus 1, that'll be minus x. Minus 1 times x, that's another minus x. And then minus 1 times minus 1, that will be a plus 1. Okay, and as you can see, guys, I put everything between parentheses because, you know, that's because that's my square, right? So I'm doing the square. And then again, I just there's this minus outside, okay? I didn't distribute the minus yet. Next, there's this minus, you distribute the minus, so minus x, minus 1, that will be a plus 1. So that's minus x plus 1, and then plus 2. Right, so that's f of g of x. Now I'm going to distribute the minus. So this minus x squared minus x minus x, and then minus plus 1. Okay, so it's minus x squared minus x, that will be a plus x, minus x, that's another plus x, minus plus 1, that's minus 1, minus x plus 1 plus 2. Okay, and then so that'll be equal to, now let's see how many x squares, just one minus x squared. How many x's? There's 1x, 2x, minus x. So 2x minus x, 2 minus 1, it's just 1x. So plus 1x. And then minus 1 plus 1, that would be 0. Plus 2, so that would be plus 2 here. Okay. So as you can see, so I did the exponent first. Put everything between parentheses. Once you are done with the exponent, then you can distribute the minus sign. So that's for the answer for f of g of x. And now for g of f of x. So that's the answer for f of g. Now g of f. Well, you can write down first g of x. So g of x, it's just x minus 1. Now g of f. So same thing, substitute this x with this f of x. So here's this x. So x is going to be now f. So f that's, minus x squared minus x plus 2, right? That's my f. And then there is this minus 1. So here's minus 1. So g of f of x is just minus x squared minus x plus 2. Again, I'm supposed to have parentheses, but here they're not really relevant. They're not really important, okay? Because there's nothing here. There's no exponent or minus or anything. So minus 1. And so it's just, so g of f of x would be minus x squared minus x. Now for the constant, I have plus 2 minus 1, plus 2 minus 1, so that would be plus 1. So that's the answer for g of f of x. All right, now for the fractions, I think the fractions are also important. So for number 2, first I'm going to write down f. So f of x is equal to, that's f is x plus 2 over x minus 3. So x plus 2 over x minus 3. Now we need f of g of x. So there is an x in the numerator right here, and there is an x in the denominator, right? So I need to replace both x's, and the x in the numerator and the x in the denominator, by g of x, right? So so this x, and we're gonna have an x here in the denominator. So so that'll be equal to, so my g is 3 over x, right? That's my g, 3 over x. So here's my 3 over x, and here's my 3 over x. All right, so in the top we have plus 2, and then the whole thing divided by, so this, the g of x minus 3. Okay, again, g of x is the 3 over x. All right, so let me write it down.
I'm sorry, Professor, excuse
Yes,
me.
please.
You're gonna have to excuse me because my next class starts in like 3 minutes.
All right.
So
No,
keep the recording. I'll review it later, and I gotta go.
sure, no problem, no problem.
I'm sorry. Thank you.
No problem. Yeah, see you next time. So this f of g, it's the 3 over x plus 2. That's the numerator, and the denominator, it's the 3 over x minus 3. All right. Now, guys, we have in the top, as you can see, we have the sum of 3 over x, that's a fraction, plus 2, it's a whole number. Now, the thing is, you can make the 2 looks like a fraction. So if you divide by 1 right here, I mean, 2 over 1, it's just the same thing, it's 2, right? Now, we have the sum of 2 fractions, so then you need the common denominator, right? So common denominator would be x, right? You kind of cross multiply. So you have to multiply here, the top and the bottom here by x. And here, we're supposed to multiply the top and the bottom by 1, right? Because that's the denominator of 2 over 1. The same thing in the bottom and in the denominator. So this is like minus 3. Minus 3, you can write the 3 like a 3 over 1. This is just the same thing. And then you need the common denominator because you're subtracting fractions. So you need the common denominator. So you cross multiply. So it's like here, you multiply by x, and here it's like you multiply by 1. All right. So then, so now this thing is just, so f of g of x. So this is just 3 over x, it's just the same thing because we're multiplying by 1. But the second fraction, we're going to have 2x over x. Okay. In the denominator, it's 3 over x minus, we multiply by x, the second fraction. So that's 3x over x. Now, again, the thing is, we need the common denominator when you add or subtract fractions, right? So like here in the top, the common denominator is x, and here in the denominator, the common denominator is x, right? The same thing. So now, so f of g. So the top, because we have a common denominator, so we're supposed to keep the common denominator, which is x, and then we add the top. So that's 3 plus 2x. Now, in the bottom, it's the same, we apply the same thing. So we have a common denominator, which is x. So we're going to divide by x. We're going to keep this common denominator. And then we're going to subtract the top. So that's 3 minus 3x. So it's 3 minus 3x. Okay. Now, actually, we are dividing two fractions, right? I mean, we have a fraction in the top. This is a fraction, and it's divided by another fraction, right? So what do we do when we divide two fractions? Well, we have to flip the one in the bottom, right? So we have to flip. So that's f of g of x. That'll be equal. So we have to flip the bottom. So in the top, we have this 3 plus 2x over x. That's my top. The denominator, we have to flip the denominator. So so we multiply by x over 3 minus the x. Okay. So as you can see, I flipped the denominator. Now, so now it's a multiplication, right? So how do we multiply fractions? We just multiply straight across. So here, it's like this thing here times. So it's like 3 plus 2x times x, and then this x times the 3 minus the x. But as you can see, guys, the x here and the x here, they cancel out. You know, because you multiply and divide by the same thing. So the x over x just cancel out. And so the answer, so f of g of x. So in the top, it's just 3 plus 2x. And in the denominator, it's just 3 minus the x. Okay. So that's the f of g of x. All right, guys, I guess we don't have time to do the g of f of x. So I'm gonna stop here. So yeah, on Wednesday, I will continue with this composition of functions. So next time I will show you how to find composition of functions using graphs. And then we're gonna discuss the domain of the composition of the two functions. All right, I will see you on Wednesday. What time is my office hours, Beijing? It's on at 2. It's from 2 to 3. All right, guys.
Hey, I have
Thank you for
a
listening.
quick question about the
Yeah,
test.
please. Yeah, please.
Will we have a review sheet or something so we can
Yes.
review for the test?
Yes. Next week, I'm gonna post like a review sheet on the CUNY Blackboard. Yes.
All right, thank you.
And then we're gonna have a review Monday before the test.
Perfect.
Mhm. All right. Thank you for listening, guys. And I will see you on Wednesday. Yeah, sure, Beijing.
All right,
I mean, take care. Yeah. I mean, we can talk now if you want. I mean, I have let's say 15 minutes before my lunch. We can talk now if you want, or I mean, we can talk at 2 p.m. It's up to you. All right, guys. Probably I'm gonna just stop sharing the screen. Okay. Last exercise. Yes. Oh, well, first, I don't know if you, do you hear me, Beijing? Yeah. Okay. The fraction, right? The number 2 you said, right? That's oh, number 1 as well. Okay. Um, okay. All right. You know what? You can probably, yeah, we can talk at, it's better to talk at 2. Um, first I need to stop recording. Stop recording.